Hi there, welcome. Thank you for joining us for Programmers Weeks. Let me introduce myself. I am Daniel Tejerina, and here with me is Alexis Moreno. We are working as a QA automation engineer at Cognizant Softvision for around 6 months. Today we are really excited to talk about Dockerizing a test framework. And we encourage you to share your question in the QA model. So let's get started. So we are going to start with this phrase: do it once and do it well, but don't forget about portability and scalability. And we think that this phrase summarizes what we will see today. And there you can see the two main keys that we can get as a benefit of Docker. I mean, portability and scalability. So the agenda for today is first of all, we talk about why Docker, how Docker works, and comparison between VMs, virtual machines, and Docker. And then we will talk about key concepts about Docker. We think that we need to refresh or maybe speak up about this key concept to let you know what we'll use in our demo. So then we will see Selenium infrastructure, what we use in our test framework. Then we have two demos, local demo and move our test framework, Dockerizing test framework to AWS service. And finally, the next steps. So let's start with why Docker. So let me share a little story to answer this question. So that story starts a couple of years ago when I was working in another company, in another project, of course. There we had our own test framework with base language in Python, and it was a BDD framework like Cucumber or JBehave, maybe. And there are many test cases automated. We had many test cases of the regression suites and many test cases of smoke suites also automated. So when we receive a new build, it was easy to and fast to know the quality of that build. We execute all our automated suites in almost 6 hours, and we can know the status of this build. So everything was good at that moment. In each sprint, we insert new functionality and new test case, of course, in our test suites. But then we have to move our test framework to, we have to move our application to the cloud. So when we try to move our test framework to the cloud, we're trying to execute our test execution cycle. There was many dependencies. There was many libraries that we don't know that's why they exist. And so as a result of this, we cannot execute the complete regression test. So we pass from 6 hours to 3 weeks doing a manual regression test. And then we have to duplicate the effort running the same in Azure when we move to Azure Cloud. So that's the good example why we need to Dockerize our test framework. Because with Docker, we gain this kind of benefits that you see at the right side of the screen. You gain portability. You can run your framework in different environments, even in the environments like development environment, QA environment, and staging also. And consistent and isolated environment. It's consistent because it takes an image as a base, and then we can run our test framework at the same in the same way in different infrastructure. So repeatability and automation, flexibility, we can create our own development environment. We will see that in the next slides, what we can do that. And agility, of course, we can move easily and fastly not only our test framework, we can move our infrastructure. We will see that to run our test framework, we need an infrastructure like a Selenium Hub and Selenium nodes, of course, and we can create fastly the test infrastructure and then run our test cases. And of course, we can escalate, create new nodes, and have more browsers to run our tests in parallel mode. As a final benefit, it is cost effectiveness with fast deployment. It is easy and fast to deploy a new infrastructure with Docker. So, how Docker works? So, at the right side in your screen, you have this image. So we can think that as a laptop where we have an infrastructure. I mean the resources of the laptop, memory, disk space, networking, and some networking stuff. So what we do with Docker is virtualize the operating system. So in a unique operating system, when we have installed Docker engine, we can run many containers. For example, each container could have it is an isolated process. It has all the dependencies that this process needs to run. So the Docker engine helps to this container to run and to get all the resource needed to execute this process. So here we have how the Docker engine works. And when we install a Docker engine, we are installing a client part and a server part and a REST API. This REST API helps to the communication between these two parts with the client and the server. And in the Docker server, when we want to create a container, we go to the image file. This image is just a system file who contains all the instruction to create that container, all the instruction, all the dependencies, all libraries that needs to run this container. So with in the Docker server, we can create that container. Then with the Docker client, we can use that container. And of course, in the Docker engine, we have many other features like volumes, like networking, and how to orchestrate that container. So When we talk about a Docker, we need to talk about virtual machines, because in the story that said before, all our infrastructure was in virtual machines. We had a virtual machine to the Selenium Grid. We had a virtual machine for each node, for a node for Firefox, for a node for Chrome. But what's the main difference of virtual machine and container? With virtual machine, we can create a machine inside another machine. So for example, if we have a machine with 16 megabytes of RAM, when we create a virtual machine, we can split these resources in each virtual machine, and each virtual machine have its own operating system and has its own resources. So the entire resources that we have in the server is split in this virtual machine. On the other hand, when we use container, we virtualize the operating system, and we just have in the container the process itself and all the libraries need to run this process. And the Docker engine helps to this container to get the resources needed. So in the container, we don't waste infrastructure resources. And other points to highlight here are in a virtual machine, boot up time is in minutes. We can create a new machine and then install the operating system, and that's it. We can create as a new laptop, for example. In a container, we can instantiate this container in a second. It's just pull the image and run this container just in seconds. There are no control version in a virtual machine, but in Docker we can get this control version, tagging our image with different version, for example, and then we can run a Docker. We can use the command docker run, and for example, our test framework version 1.0, for example. And at the end, we have for each virtual machine, we have the files for one disk. So these files can run just one virtual machine. With a Docker image, we can run multiple containers with the same Docker image. So who is the winner here in the virtual machine and Docker? I think there are no one winner here. It depends of the project. It depends what you need. For example, you can use virtual machine. In fact, we use virtual machine many years, and we don't need Docker. But when we need to move our test framework, we realize that Docker will be better. And okay, here we have three main concepts that we need to know about the Docker: container, image, and volume. So container, we can think in container is just a process running which has its own libraries. It's just it's just another process in our laptop. This process use features kernel of the kernel Linux to get the resources. It's the kernel namespace and C groups. And an image as I said, it's just a file system. It contains the step-by-step about how we will create the container. So, and a volume is the mechanism to share some directory from the laptop and the container. It is useful when, for example, when we create a development environment, and it's useful when we execute our test. It's convenient to put the results in a volume in a laptop outside the container, because if the container is restarted, we will lose all the files, all the results. So okay, now Alexis go on deep about the command and then show you the infrastructure, the Selenium infrastructure and our test framework infrastructure, and go to the demo. Thanks, Alexis.
Hi,
Yeah.
well, I'm going to explain a little bit more about Docker, and I'm going to go into deep about how to create a Dockerized test framework with Docker and Selenium Grid. Well, first, a list of useful commands for Docker. When run, we create a new container. When start, we start one stopped container. Stop with the stopped container. With Docker images, we lead the images. And then we have command to execute commands inside a running container to pull images or to delete containers. We have two features that are useful in Docker. One is Docker Compose, and the other is Docker File. Both are types of files we create. When we write a Docker file, we basically write what an image can have, and we create an image from a Docker file. And with Docker Compose, we can start multiple containers at the same time. It's pretty useful. I'm going to explain later this with an example. On another topic, well, Selenium, probably if you work on QA automation, you are familiar with Selenium. Selenium has three main products. One is Selenium WebDriver, that again, probably if you work on QA automation, you know Selenium WebDriver, that is useful to interact with the browser to automate test cases on a web application. And then we have Selenium IDE that basically records the steps you make on the browser and generates scripts. And then the last one, the one we are interested in, is Selenium Grid. Selenium Grid is useful to run distributed tests. You can run multiple concurrent and parallel tests on different devices and different browsers at the same time. Selenium Grid is very powerful. And on the next slide, we can see a little bit how Selenium Grid works. It's interesting. First, we have the client, that it could be, for example, our local machine or cloud environments with where our test framework is. And then our test framework needs to call the hub that is a part of Selenium Grid. The hub has different nodes that can be different devices that have different browsers. So this is very powerful, especially when we need to run cross-browser or cross-device tests at the same time. It's very fast also, and it's interesting because, well, there is an image of Docker Grid that we are going to use on this demonstration next. So we don't need to configure the Docker grid. We simply create the container and call the hub pretty easily. Well, we have a project to show you that basically what we do is we are going to define an image, then create the container with the, we are going to define the image or our framework, and then we are going to start the container of our test framework with Docker run, and then we are going to start on we're going to start Selenium Hub and Selenium Nodes on different Docker containers. On the next slide is basically the idea of what we are going to do. First, we have our test framework on a Docker container, and this container is going to call the hub, that is another Docker container, that have the nodes of the browsers that are another containers. We are using Selenium Grid 4. It's an alpha version. We decided to use this one because it is interesting to see what is in development. It's a little different from Selenium 3. If you want a stable version, I recommend you use Selenium Grid 3. This version of Selenium Grid 4 is, you can not escalate easily the browsers and the number of nodes you have, but it has some advantages that I'm going to show you. It's in development. You can check out the code on GitHub. It's interesting what they are doing. It's on pre-release. And next, I'm going to show you some code and some tests running of this project we were working for this talk. I'm going to show you basically three things. First, the local framework of the test of the common Selenium WebDriver that probably you already know. And then I'm going to show you the difference with going against a Selenium Grid on a remote WebDriver. And then I'm going to show you how to Dockerize your test framework. And I'm going again against the Selenium Grid. I'm going to start sharing my screen.
Okay, I stop share. Ready.
Let me know when you are seeing it.
I can see your screen. Yeah.
Cool. Well, here, this is our test framework. We are using Java. Let me show you the dependencies. It's a Maven project. We are using Cucumber. And we are also using Selenium. I'm going to show you a little bit of the infrastructure. We have a simple example test, and that goes against Google and search on different countries of a Google page. Very simple test to try this architecture. And on the other side, we have, well, the pages. And the interesting part is here. Here we configure the WebDriver. And here, I want to show you this one. I'm going to show you because it's a local Selenium project. As simple as that. The import we are bringing is selenium.webdriver. This is the simplest example of Selenium. And here also, when I configure the WebDriver, I bring in selenium.chrome or .firefox, and depends on the browser I want to test. And simply I call, I'm calling the browser I have here. Or the one in path, if you make this. This is a local example of a test framework. Yes, we are going to run the test against a local browser, a web driver we have on the path or we have in the project. And I want to show you the difference with a remote, a project that goes against Selenium Grid. Let me check out the code.
It's important to say also that we will share with you the GitLab, where is this code. And also we have the Docker image uploaded to the Docker Hub, which is a repository of all image. So then you can download the code and just run this framework. Yeah.
Yes. Well, here, as you can see, we changed the imports. We don't no longer call the web driver like this. We simply type for here, remote web driver. Yes. And here also to call the web driver. What is different here? Well, the way we call the web driver here also, we are not calling the web driver that we have on our path or on our project. We're calling the web driver with an URL. Yes, the URL of the hub here is parameterized. It's a parameter we got from system. Well, here is the sample commented out with other browsers. But this is the main difference. We no longer have the import from the web driver. We're going against remote web driver and we pass the URL of the Selenium Grid. Now, where I have the Selenium Grid, I'm going to have the Selenium Grid on a Docker container. How I start the Docker container? Well, I'm going to use a Docker compose file to start the hub and the nodes and the node, cron node for the grid. I'm going to show you comments on code. So this runs.
I can show you yeah, there it is.
Yes. Here, this is a Docker compose file. We have the image we download from the Docker Hub repository. There is a Docker Hub repository with image that there are official image that companies make with their products. We can upload. Simply we can look on Docker Hub. Let me show you the web page of image we can need. For example, well, here is ours, one of our products. But for example, if we want, I don't know, a container of Apache server, here we have the official image of Apache. We simply can pull the image and create a container without worry of the configurations of the server. It's easy like that. We search for official containers, and you can also update your own image to create containers. For example, this one is the one of our framework. As I have updated this image from our framework here, we're going to see after how to create this image from the Docker file.
Yeah, you can.
So we have.
You can get the same information when you have already installed Docker. Just running Docker search automation framework, for example, and you can see all the information in the console. So even if it is official image or not. Yeah.
Yes. Um, well, here we have two images. We have the node, the Chrome node, and the Selenium hub. Yes. We have here the port that is going to go out on our local host. In this case, because it's running on my machine, it's going to run on the machine. It's 4444. And here is the node that says, well, the host, the hub is on this container, Selenium hub. So they are going to watch each other. The node is going to subscribe to the hub. How do I start these two containers of this Docker Compose? It's very easy. I only need to, let me clear this one. Here I am on the, sorry. Here I am on the directory where I have my Docker Compose. And I only need to do Docker Compose app. And now I am starting my Selenium hub and my Chrome node. As you can see, I have that I have a dependency between the Chrome and the hub. So the Chrome is going to finish after the hub.
Can you show the
yes.
Selenium grids in the browser?
Yes. Now I can see I have my Selenium grid on my browser running. I'm sorry. There you go. Here I have my Selenium grid, and I can see I have one node that has one browser. Can I have more nodes and more browsers? Yes, but not on this version of Selenium Grid, that is the 4. On the 3, we can have, for example, different browsers on the different node, and for more concurrency, and different nodes with also different browsers. Sorry. What we have here on Selenium Grid, we have, well, the nodes we have, the URLs where the nodes are. We have the session, the active session. We don't have an active session yet. And we also have, well, here when the tests are running, we can see it here the percentage of concurrency we have. So pretty easily like this, I can start my node and my Selenium hub. If I want to run, yes.
Sorry. In the meantime, you can share the Docker file.
Yes.
Where,
give me a second. I can run my test here. My framework is local, and I have the grid on the Docker on my machine, in a Docker container. Simpler for running the test, I should do this. I have parameter size, the Docker hub URL, and this is going to run my test against my grid. Simply like that. But this is not what we are interested in. We are interested we're interested on Dockerizing our test framework. How we do that? Well, we can do that with a Docker file. It's pretty easy to make an image. It's pretty easy to make an image from the Docker container of our test framework. We simply use the image of Maven, and we said add to this image our code. Basically, it's going to copy our code to the image. And we have there the image of our framework. And then we can do things like push this image to the Docker file, as I have done. and add it here. I'm going to comment this out. What we have here. Here I'm building the container with the code I have. And I'm saying, hey, run my test, open a bash terminal and run my test against my hub that I have up on another container. So that is the reason my URL is Selenium Hub, because it's the name of the container. And run them on the browser Chrome. And here I have another thing for the reports. If I want to add value reports, there are a container for that. I'm going to comment this out for the moment. So simple. Now I'm going to do the same I did recently, but I'm going to add my framework running with the remote test all in a container. Again, I have stopped the containers that I was running before to see the running containers. I do docker ps. I can see there is nothing running. So I'm going to do docker up again. So now I'm going to start the hub, the node, and our test framework that is going to run the test against the grid. Open the terminal again here. So I'm going to do docker compose up. And now starts the hub. Now it's starting Chrome, the node Chrome. And now it's starting our test framework. I can see here, this one was down because I stopped in the container, but it's going to come up in a little bit. There you go. Now it's starting the test. As you can see, I'm loading the Maven dependencies. And now I can see here, I have my node, and here it's going to show me the sessions when the test starts. It's going to take a while because it needs to download all the Maven dependencies. There is a way of saving the dependencies on your image, yes. As simply as adding the dependencies to your code, and then you are going to have in the image. It's another option. I didn't do it. Well, this is going to take a while. I have a test run here that has already run. Here you can see when I start running the test goes against the remote boot driver, starts a Chrome session. It tells me where I can see the test running on a BNC session that comes with the Selenium Grid 4. So you can see on the browser the test running on that node. You can see what is happening on the node with this link on this section. And then it gives me the result. All the tests have passed. And then the wheels finish. I'm going to leave you with Daniel, that is going to talk how to upload our framework to the cloud, so we don't have anything local, and is infrastructure agnostic our framework while this test runs.
Okay, let me share my screen. Could you stop sharing, please?
Yes, in a second.
Okay.
There you go.
Okay. Let me know when you see my screen.
I can see it.
Okay. Okay, give me a second, please. Okay, so having the image of our test framework, what we can do to move the test framework and also the infrastructure to AWS. So here you have all the steps. The first step is create a key pairs. A key pairs is basically the key to connect to the instance of the image. So then we can create an instance, and then to avoid issues on the DNS, we can use the Elastic IP service that AWS have to get a static IPv4 address, and then open, of course, the port that we use to run our test framework, install Docker package. There you have the first step to install the Docker package. Is basically use YAM to install YAM in the case you are using an image of Amazon. So then you can add the EC2 user to have access to run the Docker commands and install the Docker Compose. Then copy the Docker Compose YAML file that Alexis showed us recently. It is the file where we have which are the images that we use to create the Selenium Grid, the Selenium nodes, and also which is the image for our test framework. And because we are using the version of Grid 4, the version 4 of the Selenium Grid, we need to modify the Docker daemon to listen in on the port 2374. It is required by this Selenium Grid, just the version 4. And here you have a link to the steps to do that. And then review the Docker service. Just run the Docker Compose app as Alexis does. So let's go to Amazon. Oh, sorry. Let's go to Amazon. Here. Okay. Here. So as I said, we can launch just launch an instance, select. Sorry, it refreshes. Launch an instance. In my case, I use Amazon Linux. Select that, and if you want, you can use the free tier. As a free tier, we have some image, some Amazon image free, but they had a minimal resource, yeah. But it is enough to run our framework and Selenium Hub and Selenium Grid. Yeah, then you can configure the network. In my case, I don't touch anything there. The size of the disk, and finally, here you can add the ports that we need. As I said, the 4444. And in my case, I open this port for the world, but maybe when you are in your project, you can restrict that access. And then review and launch. And in my case, I don't create a new instance because I already have that instance. Then you can create an Elastic IP here. Elastic IP it gets an elastic IP from the AWS service. It gets a fixed IP that we use to run our test. Then we can associate our elastic IP with our instance. Here you can see that this elastic IP is associated for our instance, and then you have to install all the Docker package. In my case, I have already installed that package. It's just for this, you just execute these 4 steps, and the step here for Docker Compose. In my case, I have this already installed. So sorry, I enter again for this session. To connect this session, of course, I'm using the key pair that I created before to create the Amazon instance. So first, I will log as a root, and then I can see the status of my Docker service. In my case, it is off. I start this. Sorry. Yes. Yeah, there. Start my service. And then once I have it started, it is some time to start. Let me see. I could see with this command, it is started right now. I could see, sorry, I could see with status command, it is running right now. And then I could see with this command, the Docker image. But in that case, we are not in the default ports of the daemon, because we use the version 4 of Selenium Grid. So we have to export this key. So now I can just put Docker PS to see all the image that I have. And then another key step is to move our Docker Compose. Here, I move my Docker Compose. I can see my Docker Compose here. Docker Compose, it's the same Docker Compose that Alexis showed us. And the main thing here is have the elastic IP here that's already created for the Selenium Grid. It is, I will review if it is the same. 54, 219, 16, 92. It is already write this. So, and now I can just run Docker Compose up to start running. And I could see here if our grid is started. Not yet. And now I have in this host the Selenium Grid, and now the test start to execute. So So it's so easy. There are a few steps to move our test framework to another infrastructure. So it is easy and it is fast and we gain some agility on that. So so having said that, I don't know. Yes, Alexis.
Before finishing, I would like to show how to escalate containers on browsers. We have 5 minutes, I think.
Okay, we have time. I don't know if, yeah, we have 5 minutes to do that. And let me talk about it a little bit.
Okay.
Yeah, as a next steps, once we have our Docker, well, we have already have our test framework Dockerized. What we can improve, we can configure our development environment using volumes, as I said. In that case, I don't need to down our infrastructure, just do the change in the code and run the test at the same time in the container that is already running. And then if we have many containers, when, for example, if we add our test framework our test framework image or our test framework container to the application itself, we can use Swarm or Kubernetes to orchestrate that image. And another solution that if we already use Kubernetes to orchestrate that our image, we can use just Kubernetes and the runtime of Docker. We don't need to install the entire Docker engine. We just install the runtime. It is a container D. It just it has the ability just to pull the image and then run an image. And I don't have other features here, but all the other features I will have on Kubernetes side. And finally, we can use build X. It's a feature of the Docker to create a multi-platform image. Yeah, and then we have 5 minutes. You can share this.
2 minutes.
This, Alexis. Okay. And in the meantime, let us know if there are some questions.
If you have any questions,
Yeah.
this is I show you quick. This is the way to escalate the browsers. Here you configure the number of sessions you want. This is the version 3 of the Selenium Grid. And simply you have here, see, this is the old version of the grid. You have multiple browsers at the same time. In your one node you have 4, and the other you have 2. And in case you want to escalate the numbers of nodes you have, simply you run this command, and that's all.
Okay, thank you. So we are opening for questions. That's all that we have for now. And to summarize, we create our test framework, then Dockerize our test framework, creating the Docker file and the Docker Compose, and then move our test framework and the infrastructure to AWS and run it. And we show you that it is easy to move all the infrastructure. Yeah. I don't know. Here I have the chat. I will review the chat. Okay, so there are no questions, but Anyway, we will share all the presentation. We will share the
And the code,
repository,
and
yeah,
if you
and
have
the
any
Docker
question,
image. Yeah, yeah. If you have any question, you can contact us through through LinkedIn or anywhere. Yeah. And thank you, Alexis. Thank you all for your time.
thanks. That will be all.
Okay, that's it. Thank you all.